So we've graphed all kinds of things. Most recently we have graphed exponentials. Today we're going to graph logs. Exponentials and logs are very much related to each other in that they are inverses of each other. Okay, so our basic logarithmic function looks like this. F of x equals log base b of x. So when we had our most basic exponential, we had f of x equals b to the x. And b could be any number, just like b could be any number here. But we need something to graph some generic function. So we use 2 for the exponentials. We're going to use a base 10 for the logs, so we can just use the common log here. So we're going to graph the exponential first, because we've already graphed those, we know what to do, right? So we get our anchor points. If I have f of x equals 10 to the x, and x is 0, y is 1, right? No matter what the base is. If x is 1, y is 10. You say it's like, up there. If x is negative 1, what is y? Come on now. If x is negative 1, what's y? 1/10. Yes, 1/10. Right, so so clearly I'm getting bigger and bigger this way, smaller and smaller this way. Am I ever going to cross the axis? No. So I have an asymptote there. Put my asymptote in there. Then I'm going to sketch in my exponential function like so. Right? Remember, no matter what the base is, when x is 0, y is 1, the other 2 points are dependent on whatever the base is. All right, so these are logs and exponentials are inverses of each other, right? So log base 10 of x is the inverse of 10 to the x power. So graphically or algebraically, to do the inverse, all we do is exchange the places of x and y. So the asymptote right here is at y equals 0 for the exponential. If I'm exchanging x and y, where would the asymptote be for the log? This is at y equals 0, it would be at x equals 0. Very good. Okay, so then we'll take the 3 points that we had over there, add this negative 1, 1/10, which means I'd go to 1/10, negative 1. Then I have 0, 1, which means I'd go to 1, 0. Then I had 1/10, which means I'd go to 10, 1. And my function looks like this. And for whatever the log is, remember, you take the log of 1 and you're going to get 0 every time. So they're inverses. That means we can exchange x and y. Graphically, it also means they're a reflection of each other in the line y equals x. So it does say up here, use your graphing calculator, but we're really not. The calculator really doesn't help us understand anything. Then it tells us that we can graph them using the inverse. We're not going to graph them using the inverse. We're going to rewrite them in exponential form, but not actually as inverses. Makes it a little bit easier to do it that way. So we're not going to do number 1, because if I do log base 3 of x, it's pretty much going to look just like this, except instead of at 10, I'd be at 3 and so forth, just because it's going to be the exact same shape. So we're going to start with number 2, where it gives us a fractional base instead of a whole number base. So what we're going to do for these, and this has no transformations, it's just a log function. We're going to set this equal to y, and then we're just going to rewrite it in exponential form. I'm not taking the inverse, I'm not exchanging anything, just taking the base to this power, so 1/2 to the y power equals x. Then I'm going to do my anchor points, but I'm actually going to make a little t-chart because we're going to be choosing numbers for y instead of x, because we always choose them for x. And just so I don't get them backwards in my head, it's not a bad idea to write them down. The y values we're going to choose every time, negative 1, 0, and 1. So if I take 1/2 to the negative 1 power, that's going to give me a value of 2 for x. If I take 1/2 to the 0 power, that's going to give me 1. If I take 1/2 to the first power, that's going to give me 1/2. Okay, so now I have my t-chart. So now when I plot them the same old way I always have, x, y. So I'm going to go to 2, -1, 1, 0, and 1/2, 1. I don't have any horizontal translations. I'm not moving left or right any. So my asymptote stays at x equals 0. And my function looks like this. Okay. Any questions at all? So now you know for exponentials, you're increasing if it is greater than 1, and then you're decreasing if it's a fractional value. So look at like this log base 10 of x has that shape right there if we have a base greater than 1, and then it's basically a reflection if it's between 0 and 1. All right, so our domain goes from 0 to infinity. Range, -infinity to infinity. That will be true for every single one of these. The domain can change. The domain will change based on whether or not we translate left or right. My x-intercept, I actually graphed it, so that is at 1, 0. Asymptote is still at x equals 0. The only thing that will affect that is if I have a translation left or right. Then I have my end behavior. Okay, so we usually start with as x approaches -infinity, but x doesn't get to approach -infinity. X is approaching, it doesn't get past 0. So x is approaching 0. Not only that, we have to be a little bit more specific now. We're going to say as x approaches 0 and put this little plus sign in the, like in the exponent. It's not really an exponent, but that means as x approaches 0 from the right, because I could approach it from the left, but I'm approaching it from the right. So as x approaches 0 from the right, y is approaching infinity. And then moving to the right, x can approach, or x is approaching infinity, y is approaching -infinity. Okay. Any questions at all? All right, I want you to scroll all the way back up to the top here. And we're going to write some of that down so that you know what's happening. So if I have x approaches a, like a is any number with the plus sign there. This reads x approaches a from the right. Okay. And if I have x approaches a, and there's a negative sign there, that means x approaches a from the left. So they're both on the right, like a little exponent, but if it's a plus sign, we're approaching from the right. If it's a minus sign, we approach from the left. Okay, let's move on to number 5. Going all the way to number 5. Okay, so on number 5, does this one have a translation left or right at all? What do you think? Do I have it like, is it going left or right? I mean, just in general, is it happening one of them? The answer is yes. So it looks like it's going to the left. Okay, so I do have a horizontal translation. Looks like it's going to the left, but here's the catch, which is not really like a catch. It's not a trick question or anything. But and all the ones that we have done so far, the coefficient of x has been 1. If there's been anything else, like it's been negative or it's been a number to do a horizontal, stretch or compression, whatever, it's been factored out every time. So in order for us to look at this and know which way we're going, the coefficient on x has to be 1. So I have to rewrite this as f of x equals negative log base 2 parentheses. I have to factor out that negative, so this gives me x minus 2 in here. So the only way you can look at that and know for sure which direction you're going, or even what the number is if the coefficient on the x is 1. That doesn't mean I factor the negative like out of the whole thing. It just has to be factored out inside of there. Okay, so at first glance, it looks like it's going to the left, but we're really going to the right once I rewrite it. Okay, does that make sense? All right, so be careful with that. Pay attention when you're graphing, these, whether or not it's written that way. If not, you might have to. So we're going to set this equal to y. Now, when we rewrite this in exponential form, I'm not rewriting the whole thing. I'm rewriting it as a parent function. The base of the log is 2. So I'm just going to do 2 to the y power equals x. Just so I get the parent function anchor points, and then I'll translate like I know how to translate. I'm going to make my little t-chart. Y is always -1, 0, and 1 for these. So when y is -1, x is 1/2. This will be 1. This will be 2. Then I'm going to write out my transformations so I don't miss anything. This negative right here means I'm reflecting in what? This first one. X. It's affecting y, so I'm reflecting in x. Good. And then I have this other negative. It's inside of here with the x, so it affects the x, which means it's a reflection in the y. All right, so I got my negative, and that 2 means I'm going to the right 2. So the first thing I want to graph is my asymptote. For the parent functions, it's at x equals 0. The only thing that affects it is if I translate left or right, and I did. I'm translating to the right 2, so my asymptote translates to the right 2. And that's a question over here, so I can say, all right, my asymptote is x equals 2. I just graphed that. So now I'm going to use my anchor points and my transformations. I'm going to go to 1/2, -1. I'm going to reflect in the x-axis, so I end up right here. Reflect in the y-axis, so I end up right here. Move to the right 2, so I'm right here. Then I'm going to go to 1, 0. I'm going to reflect in the x-axis, so I don't go anywhere. Reflect in the y-axis, and then move to the right 2. Then I'm going to go to 2, 1. I reflect in the x-axis, so I'm down here. Reflect in the y-axis, so I'm over here. And then I move to the right 2. So something else I have to answer over here is my X Intercept. I actually have graphed that. That's at 1, 0. If I didn't already graph it, I'd want to find it before I sketched it in to help myself. So now that I have those 3 points, then I can sketch in my curve. And it looks like this. So now I can answer the rest. The domain goes from -infinity to where? 2. Range is -infinity to infinity. It will be that on all of them. I already have my x-intercept and my asymptote. Now I look at my end behavior. So I always start with the left. So on the left-hand side, x can actually approach -infinity. When that happens, y is approaching -infinity. Going to the right, x can't approach infinity. X is approaching 2 from which side? The left, so I put a negative. So as x approaches 2 from the left, f of x approaches infinity. Okay. What questions do we have? Anything? All right. Let's look at, yes, we're going to do number 6. Okay, so number 6, again, looks like I'm going to go to the left 3, right? But this isn't a coefficient of 1. So I have to factor out this 1/2 to make that happen. So I'm going to rewrite this function. I'm going to write it up here so I can write bigger. F of x equals 2 times log base 4 of, when I factor out this 1/2, this will be x plus some number, and then minus 3. What is that some number in there? Not 3 over 2, because that would mean I'm multiplying 3 times 1/2, but I'm actually taking, that would mean I'm multiplying 3 times 1/2. I actually need to divide it out. Somebody say something?
It's 6.
It is 6. Very good, thank you. You're dividing by 1/2, not multiplying by 1/2.
And then always think also when you're distributing back in, you'd have to multiply the 1/2 times the 6 to get 3. Okay. All right, so I'm going to set this equal to y, so I can rewrite just the parent function part, which means this is the basis 4 to the y power equals x. So I make my little t-chart, -1, 0, 1. This will be 1/4, 1, and 4. And those are very simple to come up with, but again, I highly suggest you write them down so that you don't get the numbers mixed up as you go through. Then when I look at my transformations, this 2 means I have a vertical what? Stretch by 2. That 1/2 means I have a what? Horizontal stretch by 2. Then the 6 means I go left 6, and then I go down 3. All right, so I'm going to start with my asymptote. I did have a horizontal shift, so I went to the left 6, which means my asymptote has to go to the left 6. Right here. So now my asymptote is at x equals -6. Go ahead and fill that in. Then I'm going to do my transformations. I'm going to start at 1/4, -1. Vertical stretch by 2, so now I'm at -2. Horizontal stretch by 2, well, since instead of at 1/4, I'm at 1/2. Then I move to left 6, 1, 2, 3, 4, 5, 6, and down 1, 2, 3. Okay. Then I'm going to go to 1, 0. Vertical stretch by 2, so I don't move because 0 times 2 is 0. Horizontal stretch by 2, so now my x value is 2. Go to the left 6, and down 1, 2, 3. Then I'm going to go to 4, 1. Vertical stretch by 2, my y value is now 2. Horizontal stretch by 2, my x value is now 8. Move to the left 6, and down 1, 2, 3. So before I sketch that in, I'm going to need my X intercept, and if I could go ahead and figure out what it is, that gives me one more point to get my graph even more accurate, hopefully. So to find the X intercept, it's the X value when Y is what? 0. So I'm going to take this, can actually take the original, it doesn't really matter which one, take the original one. 2 times log base 4 of 1/2 times x plus 3 minus 3 equals 0. So I'm going to subtract 3 from both sides, and then I'm going to divide by 2. So that'll leave me with log base 4 of 1/2 times x plus 3 equals 3/2. So see, I added 3, and then I went ahead and divided by that 2. That way I have just one log all by itself here. Now I can rewrite it in exponential form. So I can do 4 to the 3/2 power equals 1/2 x plus 3. So what is 4 to the 3/2 power? How do I figure that out easily? What's 4 to the 1/2 power? It'd be 2, and then 2 to the 3rd is 8. So 4 to the 3/2 power, that's 8. All you have to do is take the square root and then cube it. So we're going to get 8 equals 1/2 x plus 3. I'm going to subtract 3 from both sides. So I get 5 equals 1/2 x. So what does x equal? 10. So your x-intercept is 10, 0. So I can put a point there. So that's where it crosses the axis, and my graph would look something like that. So then domain, we're going from -6 to infinity.
Range is still negative infinity to infinity, which it will be every single time. My end behavior. Okay, so moving to the left. X does not approach negative infinity. X is approaching negative 6 from the right. When that happens, y approaches negative infinity. And then on the right, as x approaches infinity, f of x approaches infinity. What questions do we have? Anything? Alrighty. Number 7. Alright, so I don't have anything to factor out or anything. I can just go ahead and rewrite this 1/2 to the y power equals x. Okay, so we get negative 1, 0, 1. 1/2 to the negative 1 power is 2, then 1, then 1/2. I have 2 transformations. The first one's going to be a reflection in what? Am I reflecting in the x or y? Y. And then the 3 means I go up 3. I'm going to give you a minute. You try and get that graphed. Do y'all agree with my 3 points that I have right now? Yes. Okay, so I haven't sketched anything in yet because I want to get my X intercept. So that means that's my X value when y is 0. So I'm going to have log base 1/2 of negative x plus 3 equals 0. So I'm going to subtract 3 from both sides. So that gives me log base 1/2 negative x equals negative 3. Now that I have a log all by itself, I can rewrite it in exponential form. So 1/2 to the negative 3 power equals negative x. So what is 1/2 to the negative 3 power? What does the negative do? It's a reciprocal, right? So it gives me to 2. What's 2 to the 3rd power? 8. So this is 8 equals negative x. So x equals negative 8. Oh. So my x-intercept is at negative 8, 0. So at this point right here. And that's what my graph looks like. Any questions about the graph? All right, then you go ahead and fill in the domain and range and end behavior. and check yourself with me. Let me know if you have any questions at all. Alrighty, then let's do one last one. A natural log. Okay, so I don't have anything I need to factor out of the x or anything, so I can just go ahead and rewrite the parent function. If this is a natural log, what is the base of the log? Natural log has a base of what? E, yeah. So this is going to be e to the y power equals x. So I have my little chart, -1, 0, 1. Remember, e has a value of about 2.7, something, something, something. So when it's to the first power, that's what we get. To the 0 power, you're going to get 1 no matter what. The -1 power, you get about 0.37, something, something, something. Then I have two transformations. That 3 is a vertical stretch by 3. And then the 1 means we go down 1. All right, there is no shift left or right. So my asymptote is still here at x equals 0. Then I'm going to use my anchor points. So I'm going to go to 0.37, -1. A vertical stretch by 3, so my new y value is -3. And then I go down 1. I'm right there. Then I'm going to go to 1, 0. Vertical stretch by 3, so I don't go anywhere. And then I go down 1. Then I go to about 2.71. Vertical stretch by 3, so my new y value is 3. And then I go down 1. It's about right here. So I did not plot my x value, my x intercept, so I need to go and find that. X intercept is when y equals 0. So I'm going to take 3 times the natural log of x minus 1 equals 0. So I get 3 times the natural log of x equals 1. Natural log of x equals 1/3. Then to rewrite it in exponential form, the base is e. So I get e to the 1/3 power equals x. Do you know what e to the 1/3 power is? Nope, neither do I. It would be a decimal anyway. We don't want that. That's the exact form. That's my x-intercept. E to the 1/3 power, comma 0. Now that helps me none to actually graph it, but that's okay because I got these other 3 points that will help me. So when I sketch this in, looks something like that. And I'm confident in saying the value of e to the 1/3 power is somewhere between 1 and 2. Not exactly sure where because my graph probably isn't super accurate. My domain, we're going from 0 to infinity. Range is still -infinity to infinity. My end behavior on the left-hand side, x is going to the left. We're not approaching -infinity. We're approaching 0 from the right. Y is going to a -infinity. And then on the right-hand side, as x approaches infinity, f of x approaches infinity. What questions do you have? All right, so in Delta Math, your assignment is in Delta Math. You've got to graph some, and some of them are like filling in this information. Just make sure you read the directions, and it works out pretty nicely. You also have a quiz due today at 11:59.